Okay, good morning everyone. So basically, in the last tutorial we have finished the basic design of the stage, and now this time we're going to use in Rhino Grasshopper to make this model become an interactive 3D model. It will interactive with our voice and our music, and probably we can move the cloud, change the face expressions, and also do some setting make them well interactive with the music. So let's take a look of the result. Right here is the video. You can see we have a jumping box. It will change the position and also the size based on the music. And also we have the jumping plate, or I would call this one floating plate. It will also change the color and change the scale based on the music, the strength of the music volume. And finally, about the face expressions, it will change that, including changing the eye size and change the expression based on the face. So basically, all these things, since we can do that inside Rhino Grasshopper, unlike using the animation setting way like the Maya or Blender, uh, for this one, we are just go back to very beginning and very original way to do that. Uh, just like we are coding for this model. Okay, so let's take a look. In the Facebook teaching group, I have already uploaded the reference data inside the cloud drive, and you can download it and checking how it works. But the final result will be a little bit different, so you still have to do that by yourself. Okay, so if you just copy and paste, I will find out and I will know that. Okay, so let's take a look. Basically, this tree looks very complicated, but actually it's not that complicated at all. First thing is that we can just see this script into a couple different sections. First part for sure, using Rhino Firefly to import the sound, we can catch the frequency and catch the tempo and the volume of the song. Basically, it's more about volume, and for the frequency, for the tempo, it's just because we can record the song so that we can catch the so we can catch the melody as well. Alright, so here is the first thing. Then I think for this part you can just copy and paste. And for the last part, it's always about rendering. If you want to render it inside Render Grasshopper, and also this time we can go even more advanced. We can render material setting inside Render Grasshopper. So that's the last part. Usually it will be the last one. Okay, I will move them on the right side. And the most important thing is the inner part. Okay, the inner part is always the most important part. And for this one, it's about the floating stage. And for this one, it's about the jumping box. And this is about how I transform the data of the song into the flying stage and jumping box. And this is about face expressions. So basically, inside this visual script, we separate this programming into three different parts. This is inputting, including the geometry and also the song. And this is the program for make them move. Okay? And finally, this is about rendering. Okay? So for these two things, because we already done that before, so for the following part, I will just copy and paste, and you can do that as well. I think it doesn't matter. But for the inner part, make sure you are following my operations. Okay, so for this, I will copy, and I will turn off all of this one. Enable, so that it won't work. Okay, right click. If you're choosing preview, preview is just turn off the preview of inside the 3D software, and the enable it will disable this component, so which means it will not run anymore. And very important things, every component means command inside Rhino 6. So if you create more component, it will take more of your computer resource to do the computing. So it will be super heavy and complicated. So although actually we can try to make this interactive model to do more stuff, to make more effect, but due to the limitation of the laptop, So I will just do things like this. And also, very important things is that it's not if you are working on like something like a Unity or Unreal engines, probably you can do interactive stuff, but it's still a little bit different, okay? Because for this time, it was interactive with your sound, and every 550 microsecond, it will import with data. So which means for your for 1 second, probably it will give imports 100 of times data inside, and every data have to be computed right here. So it will create million or maybe billion times of computing. So very important thing is that when you are going to design your model, try to make them simple. Some people like to use in subdivision model, but subdivision model has a problem because it actually contains a lot of faces. So that's why I ask you guys, if you want to make them move, it's better to use in just surface. It will be easier and also faster. And if you're using mesh model, make sure you will keep them the polyphase lower, just like this. I have already transformed this rocket into mesh model. So, but you can see it doesn't have much phase. Okay, and for surface model, it will save more resource. All right, so let's do this step by step. So first things, input the song. I will just copy this one, and I will not repeat that anymore. Just capture song capture is a Firefly plugin right here using song captures right here, and we can import the song. And the parallel and the precision, this slider is just to control the precision of the song, and also this one as well. And also we can use this one to start recording. Okay, so for this part, I will just keep like this. And very important things, let's think about how to import the flying state. This is the first part, and once we finish this one, we can talk about the jumping box. Okay, so for the flying stage, actually, first things I was the plate the plate inside Rhino Grasshopper was is the one which are the ones which I made inside Rhinosys, and then I import them inside. Okay, and after that, I using scale and move to change the size and proportions based on the volume right here. So let's do this first, okay? So let's draw the circle, sorry, draw the rectangle inside Rhino first, and type in copy. The tutorial for today will be a little bit long, so make sure you are patient enough to listen and follow. Okay, let's copy and okay, and I will lock all of them so that I will not touch them anymore. Select all of them, select all the curve, and I will put them into a curve layer. It will be easier for you. Alright, so now I have to choose them one by one because it will be easier. Otherwise, sometimes you will not know which part you want to do. You do for which play. So I will just go to the parameters and go to curve and Ctrl C, Ctrl V, Ctrl C, Ctrl V. Since we have 12, so I will just copy 12 times. Okay, and now it's orange color, which means there's no data inside. So select one curve. Okay, and it's better to rename. This is O1, and this is O2. Make sure you know which part belong to which part, okay? Okay, so now we have these 12 curves, and I will do some layout for them, put them together, so it looks save some space for my random grasshopper. Okay, so let's select all of them, Control G for group, and I will put all of them just inside. I will put all of them inside a curve container, so it will be easier to control. And sometimes, if just in case, if I want to control them individually, I can go here to check. So hold on your Shift key so that you can do multi connections. And right now, we don't need to see that anymore, so you can just turn off the preview. Okay, so now we have this, and we can turn off them as well. So now it has been imported into Rhino Grasshopper. So this is about the some input, and this is about input the surface. So let's take a look of our reference right here. So once we input the surface, once we input the circles, what's the things we need to do for the next? So first things for sure, we need to know what is the action we want to do for the plate. Basically, the things I want to do is that first things is to duplicate this one based on the sum value, and also it will change the size based on the sum value. And second thing is that it will change the colors. And for changing the color, it's very simple, just using the rendering part. So right here with these two things, first thing about the move. For the move part, it will help us to move the geometry based on the value and the melody. And the second thing is about the scale. So it will scale the size based on the time, based on the value of the music. So that's the two things we did in this area. And in order to do that, we need to extract the song data right here. But actually, right here, I have done a lot of things. If you remember, in the last time when we are working on the waving, the wave music visualizations, that's the things we did. So right here, it seems complicated, but actually it's not like terrible at all. So first thing is we have using record to record the data right here, and then import the record data to do the remapping. Because of the data we use, for example, my volume or my sound based on the speaker, the volume of the speaker, probably it will suddenly increase super loud, but I don't want my model change that much. So I will do remap them into another digital domain. For example, the maximum probably is 6 and the minimum is 0. Alright, so once you remap the data to this size, and I do multiply and import them into this series, and this series it will generate 12 number for me. So which means it means the 12th number for these plate. Okay, and so we can use this one to do them both. Alright, so let's take a look. So first things I will do actually is still about to do for the sound capture. So first thing, let's go out the data recorder. A data recorder right here. Okay, this is the data recorder, and for the data recorder, I'm going to use in remap. And remap you can find right here. This one, remap numbers. Okay, and you can import the value right here. Yes, you can import the value right here, and also you can import the the source right here, because there will be around, depends on your setting. For example, if I set as 12 right here, commit change, there will be 12 data right here. And right now, that's very important thing. We need to define a target domain right here. So let's go to construct domain, connect to here, and you need to define the maximum value and minimum value of the domain. So usually I will just type in a 10 slider, and the minima is 0, the maxima is 6, based on my setting right here, okay, just like this one. Alright, and also because the data recorder for now is still not a domain, so we need to make them make this one become a digital domain. So we need to use bound. That's something we miss right here. So let's go to the math and go to bounds, connect this one to here. So it will become a domain for now. Alright. So once we remap the number to here, to this side, we can start to manipulate the number and assign this one to the to here, to the scale and also the boundary. Okay, so that's how it works. And for this one, I also make another thing is here. Let's take a look. The series. So in order to give this, in order to create a multiple object, so I need to give them a series of number. So the series of number will start from 5, and every time it will add on 3, and finally it will give us 12 number. So just follow this way. Right now we have 12 number, and this one I will regenerate them and import them into this side. Okay, and for this part it's just adjustment which I using for adjust the number, because sometimes probably I think this is too large, so I don't want to change this part, so I'm using this way to just directly uh, make them twice bigger or 3 times bigger. So that's about the logic. So let's go here. This is a remap number, and here let's call out this one and type in, copy and paste. Right, so now we have a series right here. So we have adjustment right here, and finally it's about a series number right here. And for this one, this part is supposed to be 12, so we can just type in a 20 slider and type in 12. Okay, and for the minima, I think in the setting I use in 5, so just type in 5. We can arrange them, and this one, every step you will add on the data based on the volume. Okay, so that's how it works. Let's take a look about result. Okay, this part about every step, every time I will add on a number based on the value. Okay, but we have remapped them before, and this is about the starting number is the 5, and the end number, and it will generate totally 12 number for us. So for the adjustment, this part we have finished. So let's group them, and you can use the same logic to do your coding for the other music visualization part. Just like when you are working on your fundamental design project, you can do this one as well. Okay, so the next things we are going to do, let's take a look right here. So first things I use an area, and why I use an area, because I want to extract at a center point of every point of every curve. Okay, and then using a center point for scaling. Alright, and for the scaling factor, I use in this way to do that. So first things, I connect the number to here, but I still do another adjustment, and this one is a 0.02, and I add on a base minimum number, because sometimes it will become 0. So I add on minimum number is 0.1 and connect this part to the scale. And for the movement, basically for the movement, since we know we have put 12 number inside of movement, so it will generate 12 play right here. So let's connect. Again, this is about just about the adjustment. Okay, and for movement, you have to put a geometry inside and also uh, a vector inside. Finally, connect them to boundary, so it will become a surface. Okay, so let's finish this part and then let's take a look about the result, and we can try to do some tests. So first things, let's go to mesh or a surface area. Put this one inside. Put your curve inside, and you will extract the center point. And second, go to scale. I'm on scale right here. Alright, and for the geometry is the curve for sure. This is to input the geometry you want to scale up. And this is the center point. And finally, about the vector. And for the vector, we do twice adjustment. So first thing, it's again, we're using multiplications right here. Connect here, this one to this side. And I think the number we use is floating number 0.02. So let's copy this one to here, and we can change the number. Change this one side typer to floating point. Connect here, and this is 0.02. Okay. The next one is about add a minimum number, because this side it will be sometimes it will become 0 because probably the sound blade stopped, or maybe there's no sound at that period. So it will become 0. And the vector cannot be 0 when we are working on scale, because this one will always exist. It cannot become a vertex. So it will cause some problem. So we need to add on a minimum number. So let's go to additions right here. Copy. Type in 01 right here. So this is about the setting of the geometry. Let's take a look, okay? Okay, so now we have. So based on the geometries. Alright, let's stop. So this is about a scale. I will do the group again, and this one I will group, input the sound, and this is the sound data adjustment. And this is about the scale. Okay, so now since we have the scale, it's time for moving, right? So let's call out the move object and move in Z directions, and also we need to do some adjustment. Okay, and this one is the basic height, because I hope at least every box will higher than the base, around 10 centimeter. Okay, so right now the scale is very important. If you don't know, if you just draw this one randomly just based on your intuition, you don't know how much you need to move. Okay, so inside Rhinoceros, the scale is super important. Unlike Maya, basically in Maya or Blender, the units doesn't matter at all. But inside Rhinoceros, it's super important. Okay, so let's take a look. Let's go out move. Basically, if you want to find move, it will be, I think it's around here. Move, vector or geometry. Anyway, I will just type in move, and I'm going to move these geometries. And the direction we want to move is a vector z, which means we want to move up. So go here, connect to this side. Okay, and next part, actually you can try to directly move this one, but if you play, I guess somehow it will become a little bit weird. It's not like things like we want. Okay, so and also if you increase your volume, it will become weird. So we will do this one again. Just copy, connect to here, and change the volume. The basic one is that I want to move them probably 5 meter higher, and for this one, the adjustment let's take a look of the reference right here, okay? 0.5. Okay, so that's this part. Let's just type in 0.5. Not always work because the adjustment is still based on different model. And for the reference model, the setting of my reference model is a little bit different from the demonstration on the class. So it's not always working. So this part is about the move. Let's type in. Okay, so now we have the movement. Let's take a look, okay? Alright, fairly okay, but we still see the upper area because we still keep this one on. So let's turn off them. We don't need to see that anymore. Also this one as well, we can turn off them. Okay, much more clean. But in my file, right now is go up. But the things we want to do is go inside of the box. So it's a little bit different. How can we do that? Actually right here, right click on the input point or output point, you can change the sequence of the part of your data. So for example, if I want to reverse the data, you can go here and choose in reverse, and you will come out these items. So the result will be different. Okay, you can go here just like this side. You can go here and choosing reverse, so you can reverse the data sequence. And another one is that right now we apply a data number. So if you change this part into negative, we have to change this the value of the slider. So let's go to the value, and the minima I will type in -10. So now we can see a negative number inside this component. Let's type in -0.5. Okay. So right now, as far as you can see, things become negative. But it was too flattened, so I will change that a little bit. Let's take a look at the result. Alright, so it worked for now. Okay, and for this one, maybe just one. Okay. Right, just like this. So now we have. Okay, work. Alright. So now we have this one. I think we don't need to reverse this side anymore, but since we already set them negative, so every object they will move negative inside the box. Okay, so now we have this one. We can use in boundary, make them become a solid surface. So let's go to boundary surface right here, or you can go to surface and find out the boundary surface. I think it's here. Connect the geometry to the boundary surface and hide this one. Alright, so it will become solid surface. And the final part is about rendering. So for the rendering part, it's still the same stuff. So I will just copy this part, but I will explain the new stuff for you guys. Okay. So first things, I wanted to remove all of them. Disconnect boundary surface, disconnect surface, and disconnect. Alright, so again, I think we have used this one a lot of times, so I don't need to explain too much for you. You just get basic idea. And if you want, you can just copy the previous stuff by yourself. First thing is that we are going to using the gradient color to do the coloring. And finally, if you want to make them show in your Rhino, you have to use in the custom preview. So how to do that? Basically, this is a digital domain, and for the dot right here on the right side, which means L1, and for the dot right here, which means L0, and how to define L0 and L1, it depends on the things you want to using for define. So for example, right now I have the boundary, and I want to change the color based on the area size. So I using the area size to extract the area size of each face and make them become a digital domain. And once they become the digital domain, we can assign the number to the L1 and the L0. The maximum surface will be L1 and the minimum surface will be L0. So that's how it works. So let's just the reason why I make this one create a flattened one is because we need to flatten all the surface into one group so that we can make a sequence for them. Alright, so let's connect to here. And for this part, for the in-between, we need to input our surface. Okay? And finally, about the geometry, let's put them here. And what's this one? It's a very interesting one. Since it's called create material. Okay? You can just double click and find out create material right here. And what's the function of this one? This is diffuse. Which means the color of the object. And this is specular, which means the reflections of the material. And you need to create, let's say you need to create a vector for that, because as far as you can see, it will have the three different sections you need to input. So if you want to control that one, you can go to vector, okay? Then go to a union vector and connect to here and create a slider 215 flat. Okay, so you will have three different numbers right here. So you can, based on this one, to change the value right here. And what's the emission? It's about the glowing effect. So if you want to make your object glow, you can change the number right here. Okay. Again, this is another. You need to use a factor to control that. And this is about transparency. So right now I type in 0.3 and maxima is 1. So the 1 will be solid. And shine is about again that's about reflectivity of the object. So you can change that as well. Alright, so anyway, for now I will just leave like this. I don't want to make too many settings about the plate. But if you want to play with around this parameter, it's just like the thing that we did inside the layering material right here. Okay, but you need to use in parameter to control. So if you want to make this one interactive with your voice, it is possible, but it will become super heavy. Alright, so now we have this one, and turn on this for preview, and also enable this one. And now I don't need that anymore. Let's turn off. So as far as you can see, the inner plate right now, it will change the size and the pose based on my value. So that's the things I want to have. Okay, but if you want a bigger or maybe larger, you can do that by yourself. You can change the value right here, or you can do that by yourself. Maybe I want them bigger, so let's type in 0.5, and for this one maybe just 7. Okay, alright, so up to you. You can change by yourself. Alright, so this is about the basic stage design work. And okay, there's something too big and too much things, so we have to change that. Type -1. The scale. Okay, now it works fine. Alright, so this is about the basic setting of the uh, of the of the stage. And for the next part, we are going to do the jumping box and finally change the face expressions and the background color. Alright, so that's the tutorial for today. Thank you for watching. See you next time.